Alright, and welcome to Exponential Word Problems. Now in example 1 it says this: an Old Navy credit card charges 24% interest rate on all purchases. How much would you owe on a $500 purchase after not making any payments in 3 years? Okay, so let's go ahead and take a look at this. The first thing you want to ask yourself, is this exponential growth or decay? Well, whenever a credit card charges a 24% interest rate, that's always going to be an example of exponential growth. So what do you do when there's exponential growth? Well, you take the number 1 and you add that 24%, but you can't just add 24%. You have to change the 24% to a decimal. So we know that there's a hidden decimal over here to the right, and to go from a percent to a decimal, we move 2 places to the left. So we get 1 plus 0.24, which is 1.24. So this is what we're going to call our growth rate. Okay, so let's take a look at what does an exponential function typically look like in these problems. Well, we have f of x equals a parentheses b to the power of x, where a is going to be our starting value, b will be our exponential growth rate or our decay rate, but in this case, of course, it is our growth rate, and x is typically going to be some period of time. Okay, well, with all that information, let's plug in everything we know. We're going to say, you know what, we're going to evaluate this at, let's see here, we're going to evaluate this at 3 years, so f of 3 is equal to a, our starting amount is 500, parentheses, our growth rate is 1.24, and of course we're going to evaluate this after 3 years. Remember, your exponent will typically represent a period of time. So, after 3 years, or aka f of 3, how much will we owe? Well, you need a calculator that can run an exponent pretty easily. So for this video, I'm going to use the symbollab.com/solver calculator. And so let's go ahead and type everything in. So we see here that we have 500. And then from there, let's go ahead and put inside a parentheses. And in that parentheses, we had a, let's see, 1.24 growth rate. And then on the outside of that, let's see here. Oh, I don't know what that was. But let's see, how in the world are we going to put this up top? Oh, let's see. Oh, we just do that. So you'll click the little X with the square up top. And let's evaluate this for 3 years. So, long story short, your equation or your expression should look like this. We'll click go, and it turns out that after 3 years you would wind up owing $953.31. That's right, $953.31. $953.31. Alright? So you can tell that with an interest rate of 24%, the amount that you owe can actually grow rather quickly. In 3 years, your $500 has actually almost doubled, even though it's an annual interest rate of 24%. Alright, let's go ahead and look at a second example. Okay, in example 2, it says housing typically increases by 4% annually. How many years would it take a $250,000 house to increase to $300,000 in value? Okay, so let's go ahead and write down our exponential function, f of x equals a parentheses b to the power of x, where we know that a is our starting amount, and then we know that b is our growth rate or decay rate, and of course x is our time. Now it says here housing typically increases by 4%, so you know that this is growth. So we want to do 1 plus 4%. Well, remember, our decimal is implicitly over here to the right of the number, and to go from a percent to a decimal, we take this decimal and move it 2 places to the left. So I have 1 plus 0.04, which is 1.04. This is going to be our growth rate. Now notice, we said that x was our time, and here we're saying how many years would it take, so we actually don't know the time. We're trying to figure that out. So what's our function going to look like? Well, our ending value is 300,000, the value that we want, and so we'll set this equal to our starting value of 250,000 times the growth rate of 1.04 raised up to the power of x. So it's actually, in this case, it's the exponent that we don't know. Now here's what I'm going to do. I'm going to pause the video and rewrite my function up top where I have room to work down. So I would pause the video, finish taking notes, and let's see what this looks like. Okay, having rewritten my equation, how are we going to solve for x? Well, the first thing we want to get rid of is this multiplication that we see right here. What is the opposite of multiplication? Of course, that would be division. So we will divide both sides by 250,000. Okay, now when you do that, a cool little trick is everywhere you see a 0 on top and a 0 on bottom, those can actually cancel. And so really this is like saying, what is 30 divided by 25? Using my calculator, I find that that is 1.2 is equal to parentheses 1.04 raised to the power of x. Now notice that x is in the exponent. So in order to get out of the exponent, we actually have to take the opposite operation or the inverse operation of an exponent, which is a logarithm. So we're going to take the log of both sides. And remember, when you take the log of both sides, you get to take that exponent and bring it down. So I have the log of 1.2 is equal to x log of 1.04. Well, to get the x by itself, remember when two things are side by side, they're being multiplied. We can divide both sides by the log of 1.04. So let's divide this side by the log of 1.04. And when those cancel out, I'm left over with this. X is equal to the log. Remember, you can rewrite this where the log on bottom actually becomes the base. So log base 1.04 of 1.2. And let's go back to our fancy calculator, the Symbol Lab one. And remember, we have a base of 1.04. And so what are we going to do? Well, we can go ahead and delete all this. And I want to look for the logarithm. And here we can go ahead and type in 1.04. And then in this parentheses, 1.2. Click go. And we'll find that our answer is 4.648, or let's just round this to 4.65. So it would actually take 4.65 years for a house valued at $250,000 to mature to a value of $300,000. All right. Now I've got one more example, and I'm not going to work out the whole thing. I'm just going to show you a very quick setup because I think you'll be confused if you don't watch this. So bear with me for one quick introduction. Okay, here in example 3, it says a truck decreases in value by 19% annually. So this is actually an example of exponential decay. So what do you do when it's exponential decay? Well, this is where instead of doing 1 plus, you actually want to do 1 minus 19%. In this case, we would then have 1 minus 0.19, which is, of course, 0.81. So this is going to be our decay rate, which is very, very important for you to know. So from here, you would just set up the function as f of 6, since we know the time. We'd say f of 6 is equal to the starting amount of 30,000 parentheses 0.81 raised up to the power of 6. And all you have to do is go plug that in, and you'll have your answer. Alright, hey, thank you for sticking with me, and I'll catch y'all in our next video.